Good day, everyone. It's me again, Luina Gamuntan, and welcome back to my channel. Today, I will discuss the types of fluid flow. So, what is fluid flow? Fluid flow refers to the movement of a fluid, such as liquid or a gas, through a conduit or a medium. It involves the study of how fluids behave and interact with their surroundings, including the forces, velocities, pressures, and patterns of flow. Understanding fluid flow is essential in various fields, including engineering, physics, and environmental science, as it plays an important role in design and analysis of systems such as pipelines, pumps, turbines, and airfoils. The flow of liquid are distinguished into several types. These types are often be seen on real-world things and events that would serve us as a good example. So, here are the types and their example. First, steady flow. Steady flow occurs when the fluid's velocity at a point does not change over time. An example would be water flowing through a pipe at a constant speed. Pipes works by providing a pathway for fluids or gases to be transported from one place to another under the force of pressure. The material and the size of a pipe, as well as the pressure and flow rate, determine the efficiency and speed of the transportation process. Second, the non-steady flow. This happens when the fluid's velocity at a point changes over time. One example would be a faucet where the water flow can be adjusted. A faucet works by controlling the flow of water from a pipe when you turn its handle, which either opens or closes a valve. The valve, often a screw-like mechanism, adjusts the amount of water that can pass through, and when fully closed, creates a watertight seal to stop the flow completely. The third, uniform flow. This happens when the fluid's velocity at any point in a given section of the flow does not change. An example would be a river flowing at the same speed on its surface and bottom. A calm river works by maintaining a gentle and steady flow of water with minimal turbulence or disturbances. This is typically achieved through a combination of factors such as gradual slope, absence of obstacles, and balance in flow and outflow of water. Fourth, the non-uniform flow. This happens when the fluid's velocity at any point in a given section of the flow changes. An example would be a river where the water flows faster at the center than in the edges. A strong river flow is characterized by a rapid and forceful movement of water, often due to steep gradients, high volumes of water, or obstacles that create turbulence. The strong flow is driven by the force of gravity and the energy of water, which can erode the riverbed, carry sediment, and create powerful currents. Fifth, rotational flow. This occurs when the fluid particles move along the same path in a rotating manner. An example would be a whirlpool or a tornado. A whirlpool forms when opposing currents or vortices cause water to rotate rapidly in a circular motion. This rotation creates a downward suction force in the center, pulling objects and water downward into the vortex, while the outer edges of the whirlpool have a higher velocity that causes turbulence and swirling patterns. Sixth, non-rotational flow. This happens when fluid particles move in straight lines without rotation. An example would be a tap water faucet. A tap water faucet works by controlling the flow of water from a pressurized water supply system. When the handle or lever of the faucet is turned, it opens a valve, allowing water to flow through the faucet spout. The valve can be adjusted to control the flow rate and temperature of the water, providing a convenient and controlled source of tap water for various purposes. Seventh, one-dimensional flow. This is when the fluid flow parameters like velocity and pressure vary in only one direction. An example would be the flow through a long straight pipe. The flow in pipes is driven by the pressure difference between 2 points along the pipe. When there is higher pressure at one end of the other pipe compared to the fluid will flow from the high pressure to the low pressure side. The flow rate is determined by factors such as the pipe diameter, length, and roughness, as long as the viscosity of the liquid and the pressure difference. 8. Two-dimensional flow. This is when the fluid flow parameters vary in two directions. An example would be the flow of water in a dam or falls. The flow of water in falls or dams is primarily driven by gravity. In the case of waterfalls, the water flows over an elevated edge or cliff where gravity pulls it downward. The force of gravity causes the water to accelerate it as it falls, creating a powerful flow. In the case of dams, the flow of water is controlled by the release of water through gates or outlets. The water behind the dam is stored at a higher elevation, creating potential energy. When the gates are open, gravity causes the water to flow downward, converting the potential energy into kinetic energy. The flow can be regulated by adjusting the size of the gate openings, allowing for controlled release of water. 9th, three-dimensional flow. This is when the fluid flow parameters vary in all three directions. An example would be flow around a sphere or an airplane. The flow of fluids, specifically air, around an airplane is crucial for its flight. As the airplane moves through the air, the shape of its wings generates lift. The wings are designed with a curved upper surface and a flatter lower surface, which causes the air to move faster over the top of the wing compared to the bottom. According to Bernoulli's principle, this difference in airspeed creates a pressure difference, with lower pressure on the top of the wing and higher pressure on the bottom. This pressure difference generates an upward force called lift, which counteracts the force of gravity and allows the airplane to stay airborne. Fluid flow is important for engineering and design, enabling the optimization of systems and minimizing energy losses. It plays a crucial role in transportation, improving their aerodynamics and fuel efficiency. In addition, fluid flow analysis is essential in energy production, environmental science, medical applications, and manufacturing industries, contributing to advancements in various fields and improving efficiency and sustainability. I think that's all for the types of the fluid flow. Thank you for watching. Don't forget to be back for another knowledge gaining session. Bye!